Hello everyone and welcome back to Creators Classroom. Have you ever wondered how models like ChatGPT, Llama, Gemma or DeepSeek can be customized for specialized tasks? The answer is fine-tuning. In this video, we will explore the complete fine-tuning landscape from theory to hands-on implementation in Google Colab. You will learn feature extraction, partial fine tuning, full fine tuning, and modern parameter efficient methods like LoRA and QLoRA. Then, using Hugging Face transformers, PEFT, bits and bytes, and Google Colab, we will build practical fine tuning pipelines step by step. By the end, you will be able to customize large language models for your own AI projects and confidence. Let's get started.
Fine tuning is changing the parameters. Okay, changing the parameters of only some layers. I told you in the multi attention head model there will be multiple attention heads. Okay, you change the parameters of only one some head, or you change the weights in the last layer. Okay, for example, I will go to this transformer. See, instead of changing the weights, you simply change the weights of this MLP, multi-layer perceptron. No, this is the last layer. Okay, this is the last part of this transformer. Multi-layer perceptron means basically it is a group of perceptron. And what is perceptron? This one. So what you have to do? You have to change the values of these weights. Okay, if you do not change any weights and still you want to adopt the model, go for prompt engineering. And if you want to change the weights, then you go for fine tuning. But fine tuning, it will require some memory. Okay, it will require some graphical processing unit. And today I have chosen Google Collaboratory and T5 model, and that can comfortably execute in 16 GB graphical processing unit provided by the Google Collaboratory. Okay, so now types of fine tuning. Okay, now what is fine tuning? Fine tuning is changing the parameters of only certain layers. Okay, what is pre-training? Pre-training is changing the values of entire parameters. Okay, this is fine tuning. Fine tuning simply changing values of some layer. Okay, now there are, what are the types of fine tuning? The first type is full fine tuning. Full fine tuning means all the model weights are updated. Every models in the in the model are architecture remains same, but the models are updated. And what Servam AI did was full fine tuning. That means they have changed they have changed the parameters of all these things, q, kv, matrix, everything they have changed. How they have changed? By pre-training. They have downloaded a model, means they have downloaded the architecture, they have given the data of all the Indian languages, then they have pre-trained complete model. Okay, so that is called as full fine tuning. Next is feature extraction. That means you will freeze all the layer, train only the some head. For example, see, huh, see, there is a blocks. No, block one is there. Means you consider this block as multiple, a group of heads. Okay, group of attention head. So here some attention heads are. I will take laser. So some group of attention heads are blocked. There some here attention block is locked. Likewise, 12 layers, 12 blocks are blocked. But there is a final attention head. Okay, there is a final head which is used for classification. So you only train that. Okay, you only train the final layer. Okay, using your little bit of data. Okay, means you need to provide some data for training this classification model. And by training, what will happen? By training, the parameters weights will change. So this is called as fine tuning. Okay, so I was explaining you the types. Okay, giving quick overview of types of fine tuning. One is fine tuning, that is, sorry, full fine tuning. You will change all the parameters. Next comes feature extraction and the partial fine tuning. Both are similar. So both are similar in the sense, here some layers you will freeze. freeze means you will not going to change any parameters, but to some layers you are changing, for some layers you are changing the weights. And finally something called as LoRA and QLoRA. Okay, LoRA stands for low rank adaptation. Okay, low rank adaptation. And QLoRA stands for quantized low rank adaptation. I will tell you, give quick overview about what is LoRA is. Okay. Hmm. So you see here, for example, the 768 into 768, it's a matrix of query. What was the dimension of query matrix? It was 768 cross 768. Key matrix 760 cross 768. Value matrix 7068 cross 7068 in GPT. Okay, GPT-2. I was explaining. So what we do is we will take the rows same. Okay, the number of rows here is 768. Okay, in the LoRA. Okay, LoRA. So we will do two trainings, training 1, training 2, and here we will take R. Okay, means one training for columns. Okay, you can see here, this is a dimension. Now 768 is for rows and R is for columns. Okay, so we are training for rows first, and here we are training for the columns, and in the second training here we are doing training for the rows. Okay, so here what we are doing is we are taking less number of columns. Okay, so instead of taking 768 features, what we take is we take 4. Now out of 768 features I simply take 4. Okay, out of 768, if the rank is 8, means I have taken 8 features only, 8 columns only. Okay, now coming back to training the rows. Okay, so simple, here you keep all the number of rows intact, sorry, all the number of columns intact, and you simply change the number of rows. Okay, simply change the how that should be in a multiple of 4, like 4, 8, 16, 12. Okay, because this is something to do with the GPU hardware. Okay, so GPU hardware, it will expect a multiplication, okay, multiplication or any type of mathematical operation in 4 bits. I don't know exact concept behind here, behind this hardware, computer hardware, but it should be in the multiple of 4s. Okay, you just remember this. Okay, so in the LoRA what we do is we do two trainings, one for the rows, one for the columns, by keeping the lower rank. Okay, lower rank. So that's why it is low rank adaptation. LoRA stands for low rank adaptation. And what is Q here? Q is quantization. And this is very interesting. What is quantization is, suppose let's say if a model is 100 GB, 100 billion parameters, by quantization we will reduce the number of parameters. Okay, we will say भैया हमको 100 बिलियन पैरामीटर्स का मॉडल को रन करने का ताकत नहीं है, कंप्यूटेशनल पावर नहीं है, हम क्या करेंगे, इसको रिड्यूस करेंगे. ठीक है, नंबर ऑफ पैरामीटर्स को रिड्यूस करेंगे. रिड्यूस करने के बाद जो भी मॉडल बचेगा उसके ऊपर हम लो रैंक अडेप्टेशन करेंगे. समझ रहे हैं? पहले हमारे पास 100, मान लो 100 बिलियन मॉडल है, so we have reduced the number of parameters, and on the reduced model we use LoRA. That means we need very less computational power to perform QLoRA, that is quantized low rank adaptation. Okay, so this is about fine tuning. So I will take you to the practical now. So again we have to connect it. So I will run this. Okay, run this play button. It's connecting. It is saying 2 minute sessions. Okay, one session is running in the prompt engineering, and another session now I have given in the fine tuning. What I will do is I will manage the session, I will close other sessions, and I will run only this fine tuning session. So terminate other sessions. Okay, all the other terms are terminated. Now we can see it is this current session. Okay, this current session of fine tuning is connected. Okay, so I will install transformers, then data sets. Why data sets? Can anyone tell why we need data sets for fine tuning? because data sets are required for changing the parameters. Okay, in the prompt engineering we were not changing any model weights, we were not changing any parameters, so that's why we were not requiring data sets. But here we are changing, actually we are changing some layers. Okay, so that's why the data sets are required. So it is installed now. So now what we'll do is we will install GPT-2. Okay, so we will install GPT-2 model, okay, for which we have seen the entire theory, we have understood the anatomy. So I will import PyTorch, and also I will import this GPT-2 model from the transformers. Okay, so don't worry about all these functions. So I have given here. Okay, what all the functions mean. I have given all the meaning here. You can refer to them. Okay, later also. So it is importing. See how I have learned all these things. Nobody has taught me all these things. I have self-learned, okay, with the help of YouTube, with the help of ChatGPT. So if I get any doubt while reading a research paper, I will upload that paper to ChatGPT and I will ask, please explain me this topic. Okay. So this is called hustle. Okay. If you have interest really in something, real interest in something, you can learn by yourself. Okay. Now see, it has connected, means the models are imported, and also we asked Python for printing whether it is using GPU or not. Yes, it has printed it is using GPU, that is G4. And what is the RAM, virtual RAM of around 16 GB it is giving. So now we will load the pre-trained model. Okay, so what is the model name? DistilGPT2, means the name of the model is DistilGPT2. But while saving the model, what these people they have done is they have saved as GPT2LM something. Okay, so this is how the model is saved in the transformer, but the name of this model is like DistilGPT2. Okay, so now we will load the model. Okay, load the model and also will load the tokenizer. Why tokenizer is required? Because from the data sets we have to convert all the words into some tokens. Okay, see, and see these bars are completing, no, that means the model is loading. See, bar color it is 100%, here it is 100%. Okay, so all the things are loading weights. This is what very important for us. We are going to change these weights only, weights of some layers only, not all. Okay, so what is the parameters? The total parameters in this model is 82 million. Okay, now, and why I have reduced the size of model? In the prompt engineering technique, we were using 248 million model. Okay, the size of the model was 248 parameters, 248 million parameters. Sorry, because there our task was not to fine tune. Fine tuning itself it will consume some many of the computing power. Okay, so that's why we are reducing our model size here. Okay, we are using some different low level model. Okay, so now what we do? So we will create some functions, helper functions. Okay, these are the helper functions. Please, if you want to strengthen your career in artificial intelligence field, please know OOP, object oriented programming in Python. This is very important. So these definitions, functions, classes you can create only using OOP, object oriented programming. Okay, so now these OOP functions are created. Now what we do is we will create a custom data set. Okay, means data set is a library we have initially imported, and this library is used for tokenization and using for training. We need to feed the model with data also, no? So for that we need some library, and data set will help. And also data set, what we can do is we can download some already existing data sets from the Hugging Face. But today what we are using is we are training by using our own data. Okay, for example, I am having different categories. Okay, let's say crop science. Okay, so these are all the sentences. Okay, IAB scientists developed a crop yielding drought tolerant variety of wheat suitable for rainfed conditions. All the crop science related sentences I have given in a crop science category. Then all the biotechnology related, okay, you can say CRISPR Cas gene editing. Okay, CRISPR means it is something related with gene editing only, no, biotechnology. So CRISPR Cas9 technology, it got Nobel Award in 2017. Okay, Emanuela Scherfenter, so she was the lady behind this technology. Okay, they got Nobel Award. So all these you can see molecular marker, RNA interference. These are some of the sentences related to biotechnology. Now also some of the terms related to machine learning. See, deep learning, convolutional neural network, something something, random forest models, recurrent neural. Okay, these are some of the sentences related to machine learning. Now similarly related to soil science and climate, then methodology. Okay, so we are creating the data sets. Okay, so it has executed. Okay, to create the functions, then to create data sets, it will take no time. Okay, it will take easily, it will develop. Okay, now whatever the data sets are trained developed by us, we will save it as a text file. Okay, train.txt. You can see here. So this is a file. So this is the file, and the data will print here. Training file content train.txt. So this will appear. Currently I think now this collab is hanging because we are using heavy model. No, see, now it has appeared. Train.txt. Okay, we have saved the training file here, so immediately it should appear. Ideally the Python, this collaborator will immediately return here, but since we are using some very big model which is behind the capacity of 16 GB graphical processing unit, okay, so it has taken some time. So I can open this train.txt, how it will look like. See, so all the data being saved as text file. Okay, now in the same block same code snippet, we have asked for visualization. Okay, how many tokens are there, how, what is the mean length of token, what is the frequency. For example, some tokens, their frequency is around 19. Okay, 19 means the same token is appearing 19 tokens. For example, if agriculture is a token, so this has appeared how many times? Around 12 times. Okay, so likewise this is a histogram of all the token frequency, how many times each token is appearing in our data set. Okay, some descriptive statistics. Then we will create the data label. Data collator means it will understand the labels. So again we are creating some functions here. Don't worry about, please don't worry about this thing, what it stands for, because I have given all the explanation here. Later you can, if you feel difficult in understanding each topic, simply you can do is you can upload this notebook into the chat gpt and ask for easiest of the easiest explanation, and chat gpt will help you. Okay, because of time constraint I am going quickly. Okay, now, so now ultimately we have landed for fine tuning step. Okay, so which model we are downloading? This gpt2. Okay, the model name that initially gpt2, some model name was there, no? So that model. So and we are loading the model to the device means this tesla 16 GB graphics card. Okay, then output directory means we are saving the model as fine tuned model. Okay, then these are the parameters, different parameters for training. So we are using the learning rate of 5 into 10 to the power of minus 4. Usually we use 0.01, that is the ideal learning rate. So here we are using lesser than that. Okay, so if it is a machine learning classification purpose, then you can use learning rate of 0.5. So if the task is getting complex, okay, like machine learning classification is the simplest of simplest machine learning application. So more than that is the regression, more than that is the deep learning classification, more than that is the deep learning regression. Okay, so if the task getting complex each stage, what you have to do, you have to reduce the learning rate. That means at every time, suppose let's say the transformer architecture I have given you. Okay, I have given a textbook on transformer architecture. Since this topic is very complex, what you will do is in 1 hour you will take one page to learn. Okay, in 1 hour you will take, means in 1 hour you can read only one page and understand and learn it. Okay, suppose if some topic is very easy, let's say uh, biology. Okay, like biology circulation, how the heart, what is the structure of heart. This concept you might have read already in the preliminary, in the high school, in the UG. Okay, so it will be very easy to understand. So in this context, in a single hour you can read 10 pages. Okay, the learning rate is high. If the topic to understand is very difficult, the rate of learning or number of pages covered in a single hour is less. No, so this makes sense. Here we are fine tuning a deep learning model, so that's why the learning is very minimum, 5 into 10 to the power of minus 4. Okay, then warm up steps. Okay, then these are something like how many approaches we are using. 10 epoch means how many times the model has to undergo running, means how many times we call it as iteration. The model will run again and again, output will come, then back with the help of back propagation we'll find out the weights and biases. Again the model with the new weights, updated weights and bias, will run the model and will again do back propagation to find out the new weights. So likewise this to and fro, running the model and doing back propagation, running the model, doing back propagation. So this we do 10 times. Okay, so this will take some time. So now we have means here what we have done is we have given the functions. Okay, we have set the parameters only, means all these variables we have set here only, but we are not running yet. Okay, so this is the code for running. Okay, so this is the trainer.train. This is a function we have built earlier. So this should take around 2 to 4 minutes. See, this is progressing. This bar, it should come here. Okay, green color bar. See, now it is in third epoch. So each time epoch means it's a going to the output and coming back, with the help of back propagation. That makes one epoch. Okay, you can see in each step the loss function will be reduced. Okay, so what is loss function? It is something like error. Okay, error should be very less as possible. Okay, error should be less. And how loss function is calculated? So it is calculated based on mean sum of error plus regularization. Okay, I think Dr. Avinash or Dr. Vinay might have told you. Okay, so like in the lasso function, if you see, there is L1 regularization, L2 regularization, some different topics are coming here. So usually if you want to be a best AI practitioner, artificial intelligence practitioner, or a AI researcher, you need to read the statistics. You need to understand statistics very well. AI is nothing but statistics only, advanced statistics. Why all around the world people from statistical background are excelling? Is because AI involves statistics, right? Okay. Basically, you see, I am an animal genetics and breeding person. Okay, what I study is molecular genetics, breeding. Okay, but this breeding portion, no, it involves lot of statistics. So that's why I'm having some idea on statistics, and I could able to learn at least little bit of AI. Okay, and I am using AI in my research as well. See, now it has reached to ninth epoch. We are left with only one epoch. Some people will call it as epoch, someone will call it as epoch. Okay, and we are the Indians. Okay, we are having liberty to mispronounce English words. It's done. See, all the epochs are done. So now it will going to end soon. Okay, we can also see here the fine-tuned model will appear later, or in some time it will appear here. It should appear here. Okay, see, what is the final loss? 1.50%. And how much time it has taken? It has taken 150 seconds. Okay, 150 seconds. Now we will visualize in each step. We'll come back to this files again. Okay, it will take some time to appear here. We will visualize the loss. Okay, means after each approach, what was the loss? The loss should be as less as possible. You can see here, initially the loss was maximum. Okay, in the initial time. Okay, in the initial steps, but at the last steps. Okay, in the last steps there are, the loss is very less. Okay, and in each, if you remember in the parameters we set, okay, the definitions we defined, for each approach we have added 12 training steps. Okay, so that's why it is around approximately 120 steps. Okay, so you can see the ultimate takeaway message from this graph is, after each epoch, okay, after each approach, the loss will reduce. This is ideal actually. This is very good. So what is the improvement? From the initial step, the initial loss was 5.12 and the final loss is 5.13. And what is the improvement? Improvement is 97%. Okay. So means we have successfully fine-tuned a model. That means we have changed the weights. Okay, now we will compare the model. Okay, we will compare base model which is downloaded from the Hugging Face, and we will compare the fine-tuned model. We will use our model also. Okay, so what are the prompts? The prompts are these. Okay, ICR scientists developed a new variety of deep learning models trained on. Okay, these are some of the test prompts. Okay, so now we will prompt these prompts into base model developed from Hugging Face, and also we will use it on our fine-tuned model. Okay, so now, so it is, everything is set. So base model is there. Okay, then ft model is what we fine tune. Okay, see ft model, you can see the function somewhere, it has to be present in here only. So you can see here, now it is appeared here, fine tune model. So in the fine tune model, so in the checkpoints it will be, so different, dot pt, no, dot pt stands for model. Okay, dot pt, dot pkl, they represent frozen model. What is frozen model? Frozen model means you can't change the weights. Okay, so initially you change the weights and then you frozen them. That means you converted them into dot pt or dot pkl, pickle. Okay, pickle. So now we are using ft model and the base model. Okay, it has run already. It has taken 3 seconds only. Okay, very good. What is the prompt? Deep learning models trained on leaf images scan. What the base model predicted is, the base model has given some irrelevant text, and what the fine-tuned model given is, it has given some very good result. Plant diseases with over 90%. The deep learning models trained on leaf images can detect plant diseases with over 95% accuracy. Image processing extract experimental data means, see how accurate the prediction is, how accurate the model performed is. See, even though the model was very small, it was only 58 million parameter model, which is relatively very simple compared to ChatGPT, Claude, which are having like more than billions of trillions of parameters. But see the power of fine tuning. You can use this fine tuning approach for your own data. If you are having some data, you please use this notebook, and you can use the same model and train. And instead of paying lot of subscription charges for ChatGPT and Anthropic AI, you can use your own free of cost. Okay, then next prompt was CRISPR-Cas gene 9 editing technology as enabled. This was a prompt, and fine-tuned model definitely it has to give the better, because see, because we fine-tuned it with our data. Then the prompt was soil organic carbon something something. So the fine-tuned model predicted the soil organic content is key indicator of soil health something something. It has given. And finally, this is my last topic of today's discussion, that is called as perplexity. So what is perplexity? So this is the last topic. Okay, perplexity means it is used as a evaluation metric for LLMs. Okay, large language model. It is used as a evaluation criteria. Okay, so what is perplexity? Suppose, imagine I am developing a model using virus data, bacterial data, and some yeast data. Okay, I'll simply imagine virus and bacteria. You might be knowing coronavirus. Okay, you might be knowing some bacteria like pneumonial bacteria. Okay, streptococcus bacteria. Okay, so these are the bacteria. So I want to train a model using virus data and bacterial data. Okay, And after training a model, if I ask some question regarding viruses, the model will correctly answer. If I ask a question regarding bacteria, the model will correctly answer. Okay, now what I will do is I will use some masking. Okay, in the transformer model development, I was showing you we will use dropout. Okay, we will use dropout and we will use masking. And with the help of that, what we do is we will eliminate all the data, all the weights corresponding to the virus. That means simply you can understand in other way. We will develop a model only with the bacterial data. Okay, we will not use the virus data. And then we will ask some questions related to the virus. Got my point? We will develop a model based on the bacteria, but we are asking question on virus. So here the model will get lot of confusion. The model will get confusion and it will start predicting whatever it comes to its mind. It will start giving you the output whatever it comes to your mind, means the response will be very irrelevant because the model is confused. You can see the meaning of perplexity. The literal definition, dictionary meaning of perplexity is confusion. Okay, now how we use this perplexity as evolution criteria? Okay, because see, in our case we have used a model, a base model, and then we have fine tuned the same model. Okay, so now that means we are having the two models right now. One is base model and another one is fine tuned model. Okay, now we will ask some questions to both base model and to the fine tuned model. Since base model is not trained with our specific data, it will start giving some vague answers. Okay, and also if I ask some general questions to my fine tuned model, because my fine tuned model I have changed my weights and biases corresponding to my data set. If I ask a general questions to my fine-tuned model, it will give very vague answers. Got my point? Here two conditions are there. If I ask very specific question related to my data sets to the base model, it will give very vague answer. On the contrary, if I ask very general questions to the base model, it should predict very good, it should give the very good output. Likewise, if I ask my fine-tuned model with a question related to my dataset, it will answer very good. But if I ask some very general question, my fine-tuned model will give you very wrong answers. Okay, let's see that. So, so we have developed some definitions. Okay, definitions, that is OOP programming, object-oriented programming. Okay. Now see here some scores. Okay, after giving the perplexity, okay, after running perplexity, the model will give some scores also. Okay, you can see here what was the question. ICR Research Institute developed draft tolerant. Okay, it is something, means it's very specific to my domain, very specific to my data set. Okay, the base model perplexity score is 162. Okay, means higher the perplexity score, more is the confusion. See here, for some question related to ICR Research Institute developed a draft tolerant, because this data we used for training our model, no, fine tuning our model, no. So that's why the base model, what is the perplexity score? 162. But for the fine tuned model, okay, for the fine tuned model, the perplexity score is less. Okay, this is a good indication. Why the fine tuned perplexity is less? Because we have used the same data for training. No, it's like very good. Now, second question, which is again related to domain. Domain is related to our data sets. Deep learning model detects plant disease from leaf. Okay, this was the sentence present in our data set. Now see, for the base model, the perplexity score was 615, very high. For the fine-tuned model, okay, where we included this data, the perplexity score is less, 119. Okay, which is way lesser compared to the base model. See the power of fine-tuning. Okay, with the help of fine-tuning, you can get very good answers, very good predictions for your model. Okay, if you want to do Python coding with the help of generative AI, download all the Python related programs present on the GitHub. Okay, you go to the internet, wherever the Python codes are available, you download all of them. Okay, then you fine tune a model. Then you ask for some specific programming, then you see it will give very very good perfect codes. Without any error you can run those codes, that much perfect accurate code it will give. Or simply what you can do is you can do prompt engineering also. You can download all the, like many of the Python codes or R programming codes from the internet, then upload them into chat gpt. Okay, that means you are giving the context and tell the chat gpt for role playing. You imagine yourself as a best coder, best programmer in the world, and now say the context. The context is I have given you already some Python programming codes. Now you ask for task using this information and as a role, provide me code for developing a mobile application. You see the magic happens there. Okay, so now we will also see some we have performed some perplexity test for out of the domain. Means these are the data which was not there in our data set. Okay, this was the data which is not there in our data set while fine tuning. Okay, so for this, okay, the stock market showed significant volatility due to blah blah blah. Okay, the base model, because it's a general model, okay, having lot of weights. Okay, so its perplexity score is 179. And see our fine tuned model, we have fine tuned, while fine tuning we have changed some of the parameters or some of the weights and biases of the base model. So what happened, the perplexity score increased like anything. 5400 means it's a very vague answer it has given. Okay, now the goalkeeper made a brilliant save in the final. That means it is not there in our, it was not there in our data, it was out of the domain question. Perplexity has given very miss sorry, I am sorry, the base model has given you the less accuracy, sorry, less perplexity score of 26, and the fine tuned has given 89. So here the best prediction is 26. Actually this is very good result. Means I can say our model is performing very best when the data is something related to our domain, it is giving less confusion. And when the data is something out of the box, out of the domain, then it is giving very vague answers. Okay, so this is very good learning. Okay, so this is about fine tuning.